Good morning. How are we doing this morning? Anyone else feel a little bit rough from last night? I'll try to keep sharp. I think I like Gordon Biersch a little bit too much. Okay, so before I dive into the subject of exploring VDI using VMware and OpenStorage, I want to tell you about myself. I've been doing this for a little while, basically focusing completely on infrastructure, components, networking, OS, security, virtualization. I first started out actually in hardware engineering for a short period of time, and after that my local area couldn't support it, so I had to find different avenues. So I'm going to tell you about what I've been doing in the recent time and some current activities. For the past year, what I've been doing is I've taken WCB's environment and transitioned it from proprietary storage to OpenStorage. And that project is an outstanding success. We've had no issues at all. Performance is awesome. And we've gained the feature sets of OpenStorage. As you can see, we run 150 VMs in the environment. It's an end-to-end solution, so there's a primary site and a DR site. It's linked with 1 gigabit, and it's replicated. There are multiple levels of replication, but generally we replicate every hour, and we send all our delta across that segment of 1 gigabit. We could probably do it every 15 minutes or continuous, because there's not a lot of delta after a while. Startup would be awful. You'd have to wait a few days for startup to transfer. It's about 8 terabytes. All the ZFS send receive functionality is done through scripts. All the automation is done through scripts. Every single day, the entire DR site, VMware environment, is brought online. Every single VM that existed in production is turned on, tested, and validated that it works. So no matter what, I can tell you, ZFS replication works great. I know it's all there. I know it's all there every day, and it didn't cost me a cent for a license to replicate. It's awesome stuff. It's never gone down. I've never had an outage. The only time we ever see any ripples or bumps is when we're doing a software upgrade of the storage head. It's a clustered storage head. You see a brief interruption of about 60 seconds. Everything quiesces, it slows down, and then it comes back to normal and it carries on. Then you transition back to your other head, same story, same scenario. It transitions in about 60 seconds, you're back to normal. So you just wait for a quiet time to do that kind of work. So my current activity, well, of course, exploring VDI using OpenStorage. Everyone knows that the cost is a great reason to look at OpenStorage. It is phenomenal. Detaches us from proprietary hardware, which is a big issue today. You get sucked in, you got to buy it all. Obviously, OpenStorage has excellent features for VDI. It has all kinds of bits and pieces that we would use. I don't have to repeat them, you can read them off. But before I started doing VDI, I had some apparent challenges within the operating systems. So with any operating system, we're always presented with a significant amount of I/O noise. And what I mean by noise is it's I/O that we will throw away, like swap, like temp files. And unfortunately, by default, OSs tend to place those in areas you do not want them to be in. Primary volume, for example. If you place all your storage on C volume and it's primary, it's mixed I/O. There's no way to tune it. There's no way to clean it up. So that's one of the major challenges. Also, user data is presented in the same volume by default. We have profiles, internet files, all default in the primary OS, and that's pretty lame because it doesn't need to be there. Swap, again, is also presented in the same area. So we really need to tame this 1,000-pound gorilla and manipulate things so that we can organize the file system so that we can optimize the behaviors, take that temporary storage, move it away from certain logical stores, and manage it a little bit better. And that's what we're going to do in these next few slides. Obviously, we need some security elements. We can't just rely on a storage head that's sitting by itself. We need to replicate it to another point or provide some snapshot backup, something. And there's another interesting aspect to security. Generally, administrators help users recover their data. That takes a lot of resource and a lot of effort, and it's time-consuming, it's complex. It's really not necessary if you provision a little bit closer to the user. So in Windows, for example, if we use VSS, allow it to keep track of previous versions, we can grant the ability to the user to recover their own data. And that presents some challenges on OpenStorage, because VSS is a snapshot technology. Unfortunately, we're probably using snapshot technology underneath to protect it. So what we're doing is we're capturing a snapshot of a snapshot, which is going to consume a lot of storage. So there may be some things we want to think about when we're placing choices for our user data volumes. The virtual storage performance, well, it certainly departs from the traditional way of tuning things because it's not really hardware. It's threads running on the CPU accessing devices underneath. And they behave differently. And you're going to see an example of that a little bit later. Another important aspect is if we're going to use dedupe, we have to be careful about overloading the dedupe tables. And things that would overload our dedupe tables are user data. User data is highly unique, highly random. It's going to flood a dedupe file system with a bunch of check if this is a duplicate requests. Most of the time it's going to say, nope, create a new block, save it. And when it does that, it's going to use more memory every single time until it exhausts. So you have to put governors to keep dedupe from running away from you. And that's something I learned on a few different benchmarks. Okay, so to address some of these challenges, what we're going to do is we're going to bring the functional storage head much closer to the hypervisor and the other VMs that are using that storage. And basically what it's going to do is it's going to keep thread processing closer together. Lower latency, better reaction time. At that point, within the same element, we're going to use different I/O strategies, different volume stores, to enhance the way it behaves. Stuff like dedupe where it makes sense. A great example of that is the OS itself is primarily static, DLL, static executables. There's a little bit of noise in it, but primarily a great dedupe candidate. So some of the ways we can leverage it is by targeting specifically. And those features are dedupe, compression, etc. The ability to decouple from hardware, meaning we don't want to be attached directly to specific motherboard, specific hardware. We can detach from it by using the hypervisor model. So it's always presented with the same hardware, giving us the ability to jump around. And you'll see where that comes into play. Okay, so let's look at the first model that I've drawn up on this case. Is basically an encapsulated storage VM, reprovisioning the existing disks underneath, bringing it up to NFS, and provisioning it to its hypervisor, so provisioning to itself. There are quite a few benefits to it. It didn't cost you anything. You had to buy the server anyway. So it's a single server model. The expense item, CPU and memory. And time to configure, of course, we always forget that. So as we take that model, we can expand this model out. It gives us a low-tier scalability. This is not a highly scalable scenario. Do not attempt to go beyond 250, 300 VMs in this type of environment. If you do, you're going to have to change the model a little bit. Because if you attach to a single storage VM, or even a pair, there's a limit. You have to multiply your storage heads exponentially as the number of VMs grow. So in this model, we're able to take the initial architecture and grow it. We can bring additional hypervisors online and use the existing storage. We can also take care of some of that security requirement by replicating that storage head across to another VM. So it's actually another copy of all the data. So you lose storage head 1, it's available on a second one. Okay, so if there should be a need to expand out and go beyond the encapsulated disks within the subsystem, we could quite easily attach to external storage. And that can be provisioned with multiple methods. You could use iSCSI within the VM itself. You could use raw LUNs attached from the underlying layer. You could use VMDKs provisioned through shared storage externally. So there's lots of methods of providing that capability. It also brings us to the level where the VM itself is no longer attached to the local disk. It's only external. So all the IOPS go over the network. There are some disadvantages to going over the network, but scale is what it's all about. So once you have a single external store attached, you have a new feature that's available to you with this architecture. You can actually duplicate the storage head. You can mirror the storage heads on the external stores. So you can duplicate all the data. And what's nice about that is, what if the data were far away? It could be in another building, another city. So you can actually create a DR scenario with a single VM inside of a hypervisor attached to external storage remotely over iSCSI. Again, keep in mind that this is not highly scalable. Okay? It's not meant for extreme density, not 10,000. In the case that the availability levels have to go to subsecond non-interruptive, you can leverage VMware's fault tolerance, get zero downtime. There are a few things you have to do. You can't use VMDKs in the same manner. You have to use them externally, like something that's transparent to VMware, iSCSI, or a VDM. And with that model, of course, we can transition one VM storage head to another hypervisor. So if you have a hardware scenario where you want to give it a better server with more CPU, you can move it around. I get asked this question all the time. And I thought it would be the same issue. I thought, okay, if I take an existing disk and I reprovision it, it's got to be slower. You think logically it's got to be slower. But speed isn't always about disk access. There are other things in the way. So I did a little testing, and what I found was that when you do this, you get some interesting results. The bottom line is a VMDK clone. In other words, a VM clone from an existing disk on the hypervisor to the same disk. It was started before the second line, which is the same clone operation to the same disk, however it's reprovisioned through OpenStorage. It finished before and started after. It's the same disk. So it's a misnomer. It does accelerate things, but for reasons not because of the disk. Because it coalesces, because it's more concurrent, it's the thread processing smoother, it works better with the hypervisor. So there's all kinds of reasons for it. Metadata, unaligned writes. So there's a lot of optimizations that occur that we can't even see inside of OpenStorage head.